In the embryonic human heart, complex dynamic shape changes occur rapidly, making this development difficult to visualize and understand. In this work, we explored two mixed reality-based teaching approaches that enable educators and students to transcend the limitations of traditional classroom learning. We developed and compared two distinct didactic approaches, resulting in a single-user and a multi-user application. The single-user environment is a standalone application, which was developed to enable individual exploration and self-directed learning. Learners can familiarize themselves step by step with each development stage by interacting with virtual heart models at their own pace and examining specific aspects of embryonic heart development in detail. To further enhance the learning experience, an audio guide was integrated to provide comprehensive insights into each phase and to facilitate a step-by-step exploration through the application. The environment contains three main components: a timeline displaying an overview of all phases and the current stage, an interactive 3D model of the heart with various manipulation and selection elements, and a phase-specific information panel summarizing details from the audio guide. We aimed for a high degree of interaction and allow users to deform the embryonic heart according to its physiological development through hand interaction. Crosses on the virtual heart indicate where the deformation should begin, and dashed arrows show the direction of growth to transition the model from one state to the next. Simultaneously, an orientation frame with anatomical directional labels is displayed. Buttons allow users to explore the animation using the buttons or a slider. A separate player lets users start, stop, fast forward, and rewind the audio. Another button allows switching between deformation mode and transformation mode, with the latter enabling free scaling and rotation. It is also possible to navigate through all completed phases via the timeline. The multi-user application was designed to enable real-time collaboration and includes roles for teachers and students, modeled after traditional teaching methods. Here, we opted for classic controller inputs by realizing 3D object manipulation interactions. A directional beam permanently appears from the controller, generating a cursor at the intersection point as soon as it hits the surface. This cursor is individually colored for each player, enabling communication and user allocation. Annotations appear at the respective position of the object as soon as the cursor touches it. Additional control elements are only available to the lecturer. This includes buttons for skipping backward and forward through the phases and for manipulating the animation using buttons or a slider. Furthermore, the lecturer can switch annotations, an orientation grid, and further information about the current stage on and off. We conducted a user study involving medical students and lecturers to examine the differences in educational outcomes between these applications. Our findings contribute to understanding how mixed reality could be tailored for anatomy education.